Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 922, sort array by parity 2. Given an array of integers nums, half of the integers in nums are odd and other half are even. So odd and even numbers are in equal amount, right? In this array, the number of odd and number of even is equal. Sort the array so that whenever nums of I is odd, comma I is odd. Okay, we want to sort in such a way that the element should be also odd and the position also odd, right? Whenever nums of I is even, I is even. So whenever the element is even, the position should be also even, as they have told us that the number of odd and number of even is same, right? So we can still achieve this array, and we want to return the sorted array at last. Fine. Let us see the first example. Just see this example. In this example, we want output as like 0th position, first position, second position, third position. It is a 0th position. It is even position, right? It is even position. In even position, we want even number. Maybe 4. It is odd position. In odd position, we want odd number 5. It is again even position. What I want to get? 2. Again odd position. What I want to get? 7. Right? This can be one possible answer. This can be one possible answer. And other possible answers are 2, 5, 4, 7. Maybe 4, 7, 2, 5. Maybe 2, 7, 4, 5. Right? These can be my answers. They didn't give us to sort in relative order. They didn't give us to sort in relative order. If they have given in to sort in relative order, only this can be my answer. Only this can be my answer, because first 4 occurs, here also 4 occurs. Here first 5 occurs, here also 5 occurs. Here second 2 occurs, second 2 occurs. Right? So they didn't give us to sort in relative order. So we can possibly give these 4 answers. So this is what the question states. Now how to approach this problem? Here I have easily gave even and odd numbers, right? So first of all, whether I can store even and odd numbers separately in individual array. Let's take it even, odd. I am going to store in individual array. As it is a size of 4, we can choose even an odd array of size of 2, right? So now here even numbers are 4 and 2, and odd numbers are 5 and 7. Fine. Now just take a resultant array of size 4. Now first of all, it is 0th index, first index, second index, third index. In 0th index we want to place even number. So take this even number and just put in the 0th index, right? Now in this odd place, in this odd position, we want odd number. So take this odd number and replace here, right? Now take this 2 and put here. Take this 7 and put here. Now this is my result. Right? So this is the first approach. What's the time complexity? Time complexity is we are traversing the array once. Because we just going through this array, and whether if it is even, we want to push here. If it is odd, we want to push here. That's all about it. So the time complexity is O of n. And talking about the space complexity, it takes a even and odd. Here it is n by 2. Here it is n by 2. Totally it takes of size n, right? And we don't consider this. Because it is a resultant array. Usually we don't consider the resultant array, right? So the space complexity is O of n. Fine. So this is what the answer we have arrived. Can we optimize it? By in such a way that can we reduce the space? Fine. If they haven't given relative order, shall we use two-pointer approach? Because we have already studied that by using two-pointer, we cannot achieve the relative order, but still, when there are two different conditions, that we want to rearrange the elements, we can use two pointers, right? So shall we use 2 pointers here? That's my next question. Okay, fine. Okay, let us proceed with that 2 pointer approach. What's the question? 4257. 4257. Now this is my array. This is my array. Let's take, this is a resultant array. Just take for example, this is a resultant array. In 0th position, I want always even number. In first position, I want always odd number. In second position, I want always a even number. Again, in third position, I always want odd number. So instead of checking whether it is even or odd, whether I can use a different approach, like I can start even from here and odd from here, and when I move two steps ahead, that is from 0 to 2, from 1 to 3, I can traverse through whole odd even numbers, right? This even number always tracks to even, and this odd number always tracks to odd number, right? So this is my first intuition. Okay, fine. Now how to convert, like how to sort these elements. Just see here, 4 2 5 7. So we have seen that here is my even pointer and here is my odd pointer. Fine. Now this even number is at a correct position, right? It is at a correct position. 4 is at a correct position. We always do first thing in 2 pointers, always we fix 2 pointers. We place 2 pointers. Then second step is we place or move both pointer and place them at a wrong position, right? We place the both pointers in the wrong position, and then while swapping that wrong position, we will get a correct position, right? This is what our approach. No. We want to check here whether this 4 is at correct position. Yes, because 4 is even, and 0 is also even, right? Even pointer is pointing to even, but in wrong position, even pointer should point to odd. So I want to move 2 steps ahead. So 2 steps ahead. Now my even pointer points to the odd number, so it is at a wrong position. Right? It is a wrong position. Now we can check for the odd pointer. This odd pointer is pointing towards even position, right? So that is even number. So these both are at wrong position. Then I want to do swapping. So take this 5, take this 2. Fine. Now go two step ahead. Odd pointer comes here. Even pointers move outside. So my loop will be terminated. So this is what my observation, and this is what my intuition, and this is what my approach. Now talking about a time complexity and space complexity. What is the time complexity and space complexity? Let us write here. What is time complexity? It is O of n, because we are traversing only one time through this array, right? Now what is the space complexity? We haven't used any extra space. So the space complexity will be O of 1, right? But still whether this gives us a relative order, whether this approach gives us the relative order. No, right? Because as we know, in 2 pointer we don't get any relative order. So this approach don't get any relative order. Just right here, relative order. We don't get relative order, right? In 2 pointer approach. Always note that point. We don't even get the relative order, right? But still, if the question is in relative order, if the question is if the question is sort in relative order, then take the same example. You want to use a different approach. In that we can take a resultant array directly. Take for example 0, 1, 2, 3 of size 4. Now take 4. Whether this 4 is even or odd. So it is even, right? So even. So what is the first place for even? It is 0. So place here. Now move the even pointer here. Initially even pointer is at 0 here. Now it is moved here. Initially my odd pointer is here. Now again I want to check whether this 2 is even or odd. It is even. So place an even pointer. Move the even pointer here. Now again check 5. Whether 5 is even or odd. So place here and move my odd pointer here. Now whether my 7 is odd or even, it is odd. So place in the odd position and move my odd pointer. Whether there is any elements out of this elements, no, there is no elements. So my program stops. So this is the second approach. Sorry, this is the third approach. When they gave us to output the array in a relative order. Fine. Talking about time complexity and space complexity. What is the time complexity and space complexity? So time complexity is O of n because we are traversing only once to this array. And what is the space complexity? It is O of 1. We don't consider this resultant array. The resultant array won't be considered anytime. Okay. It is not in place. This approach is not in place, where 2-pointer approach is in place approach, right? So this is what the approach is. Shall we see the code? So this is the first approach, where I used to do like one odd array and another even array, and just iterate to every elements. If the element is even, I will push to even array. If the element is odd, I will push to the odd array. Then I am just keeping a resultant array. Now inside that resultant array, first I want to push the even in this, and next I want to push the odd in this, right? That is when the I is equal to 0, first I want to push the even arrays first 0th index. Then I want to push odd array 0th index. Then when I becomes 1, I will push the next elements. Then I becomes 2, next elements. I becomes 3, next elements, like that. Then I will return this result. Let's run this. This is the first approach. I have told you. Let me submit it. Yes, it is submitted successfully. Now let us see the second approach. Sorry, we can see the third approach, then we can see the second approach. That is, the third approach is we want in relative order without using the extra space other than the resultant array, right? So see here, I initially declare the resultant array for the size of nums. Then even pointer should point to the 0th position and odd pointer should point to the first position. Now I am traversing one element from nums. If the element is even, then I want to store in the even index, right? That the index that is pointing by the even pointer, right? And then I will make the even pointer move 2 steps ahead. Then if it is odd, I will do for same for the odd pointer. Then I will return the result, right? This is my third approach, when we want the relative order without any space other than the resultant array, right? Then coming to the optimal approach, when we want a non-relative order, we just want array that satisfy the conditions, but it doesn't say about anything about a relative order, right? In that case, first I will point the I will place the even pointer at 0th position and odd pointer at the first position. Now while even is less than len of nums and odd is also less than len of nums, right? Fine. Now if my nums of even is at the even position, whether it is in wrong position or right position? It is in the right position. So my goal is to make these 2 pointers in the to place them in the wrong position. That is, even pointer should point to the odd number and odd pointer should point to the even number, so that when I am swapping, this even number comes to the even position and this odd number comes to the odd position. That's my goal, right? So whenever I see that even pointer pointing to the even number, I make this even plus 2, like that for the odd pointer too. Else I will swap them. And I will increment 2 pointers 2 step ahead. Right? This is a simple approach we have already seen. Now return nums. So this is when we want to use this approach, when they haven't told us there is no relativity order, just give me the answer that satisfies the condition. So these are the 3 approaches for this problem. Thank you.